Today I am going to talk about sections 5.1 through 5.3. 5.1 has to do with indirect proof, which is another way of writing a proof than what we've been doing so far. So in order to prove something indirectly, you assume that what you want to prove is false and you look for a contradiction. So the steps involved with this are number one, list the possibilities for the conclusion. In general, it's either true or it's false. The second step is assume that the negation of the desired conclusion is correct. And then the third step would be to write a chain of reasons until you reach an impossibility. This will be a contradiction of either A, given information, or B, a theorem, definition, or another known fact. For step 4, you state the remaining possibility as the desired conclusion. So let's take a look at an example of a proof that can be done indirectly. So in this example, I'm given that angle A is congruent to angle D, angle AB, segment AB is congruent to segment DE, and also that AC is not congruent to DF. And I want to prove then that angle B must not then be congruent to angle E. Now, if you think about it, it makes sense. If I knew that angle B and angle E were congruent, I would be able to prove that these triangles are congruent by angle, side, angle. And then I would know that AC is congruent to DF. But I've been told that it's not. So we're going to write this proof indirectly by starting with the negation of what we're trying to prove. So either angle B is congruent to angle E, or angle B is not congruent to angle E. So we're going to assume the negation of what we would like to prove. We're going to assume that angle B is congruent to angle E. From the given information, we know that angle A is congruent to angle D, and AB is congruent to DE. Hence, triangle ABC is congruent to triangle DEF by side, angle, side. Further, AC is congruent to DF by CPCTC. But this is impossible since AC is not congruent to DF is given. Therefore, our assumption is false, and angle B is not congruent to angle E because this is the only other possibility. Section 5.2 is all about proving lines are parallel. There are several theorems that go with this. Our first theorem says it's called the exterior angle inequality theorem. And what that says is the measure of an exterior angle, in this picture here, this is our exterior angle, is greater than the measure of either remote interior angle. So this angle here has to be greater than this angle, and it also has to be greater than that angle. Now, to really understand this theorem, you need to understand that an exterior angle of a triangle is equal to the sum of the remote interior angles. So that you really understand this, I'm going to name a few more angles. I'm going to name this angle, angle 3, and then my exterior angle, I'm going to name angle 4. So I know that the interior angles of a triangle sum to 180. I also know that because my exterior angle here and angle 3 are a linear pair, that they also sum to 180. So I know that the measure of angle 3 plus the measure of angle 4 is equal to 180. Therefore, I know that the sum of those two angles is equal to my exterior angle. And that's where the exterior angle inequality theorem comes from. This exterior angle has to be greater than either of the remote interior angles. Now, the main theorems that allow us to prove that lines are parallel are listed here. They are theorems 31 through 35, and what it says, if two lines are cut by a transversal such that alternate interior angles are congruent, then I know the lines are parallel. Or if alternate exterior angles are congruent, I know the lines are parallel. If corresponding angles are congruent, I know the lines are parallel. If same-side interior angles are supplementary, I know the lines are parallel. And if same-side exterior angles are supplementary, I also know the lines are parallel. So there's 5 theorems that will allow us to prove parallel lines. Theorem 36 says that if two coplanar lines are perpendicular to a third line, then they are parallel to each other. And that makes sense here. If I have two lines, A and line B, and I know that these coplanar lines are perpendicular to a third line, C. Look at these two angles here. Then they must be parallel to each other. Notice what kind of angles these are. These are corresponding angles. I'm going to prove Theorem 36 as an example of writing a proof involving parallel lines. So in our example, I know that I'm given AB is perpendicular to BD. Here's AB, and here's BD. And CD is perpendicular to BD. Then I'm going to go ahead and prove that these lines are parallel because I have corresponding angles congruent. So we're going to start by just writing our given information. AB, or at least the first statement, AB is perpendicular to BD. That's given. And because it's perpendicular, I know that this angle is a right angle. I'm going to state that right away. Angle 1 is a right angle. And my reason here is if perpendicular, then they form right angles. I could also write definition of perpendicular because that's essentially exactly what I wrote. My next statement is the next given. CD is perpendicular to BD. And then I am going to state that angle 2 is a right angle. And again, I know that by definition of perpendicular, or I can write it as an if-then. I generally prefer an if-then. If perpendicular, then right angle. Now, in order to prove that these lines are parallel, I have to show that these angles are congruent. Now, since they're both right angles, I know they're congruent. That is a theorem. So I can now say angle 1 is congruent to angle 2. And my reason is all right angles are congruent. And then finally, I'm ready to prove that my lines are parallel. AB is parallel to CD. And my reason here is if corresponding angles are congruent, then lines are parallel. Here is another proof. I'd like you to try it. Press pause on your video, and when you're ready for the answer, press play again. Okay, so I wanted to prove that PQRS was a parallelogram. In order to do that, I needed to show that opposite sides were parallel. So I started by proving that PQ was parallel to SR. And I knew that because angle 1 was congruent to angle 2. Those are alternate interior angles, and therefore PQ is parallel to SR. That's my reason. If alternate interior angles are congruent, then lines are parallel. Then I want to be able to say angle 3 is congruent to angle 4, because that would allow me to prove that QR and PS are parallel. But that's not what's given. What's given is this whole angle here, PQR, and this other whole angle, RSP. So I stated that these were congruent because I knew then angle 3 must be congruent to angle 4 through the subtraction property. I have this whole angle, subtracting that part. This whole angle, subtracting congruent parts from congruent angles, yields congruent angles. Now, these two angles are alternate interior angles. Therefore, I know, since they're congruent, that QR is parallel to PS. If alternate interior angles are congruent, then lines are parallel. Then I finally know that PQRS is a parallelogram by the definition of parallelogram. A postulate that is given in this section says, through a point, not on a line, there's exactly one parallel to the given line. And if you take a postulate as a statement that we accept as true without proof, if you think about it, this one would be kind of easy to accept. If we look at my line here and my point, there's no way to draw a parallel line to this line through that point except one way. There's only one line. And again, the markings for parallel look like little arrow symbols. Now, there are 4 theorems that involve parallel lines that allow us to conclude that certain angles are congruent. These are theorems 39 through 42, and it says if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent, and I don't know why, but our book calls theorem 37 the exact same thing as theorem 39. If parallel lines are cut by a transversal, then corresponding angles are congruent. If parallel lines are cut by a transversal, same side interior angles are supplementary. And finally, if 2 parallel lines are cut by a transversal, then same side exterior angles are supplementary. Theorem 38 says this: if 2 parallel lines are cut by a transversal, then any pair of the angles formed are either congruent or supplementary. The proof of this is shown below. So this can be proven by picking any of the angles in a diagram with parallel lines and a transversal and calling it X, and then developing what the other angle measures must be. So if I look at my first diagram and I label this angle X, I know the angle that is opposite it is also X because vertical angles are congruent. Then further, I know that each of these angles is supplementary to its adjacent angle because they form linear pairs. So each of these angles has to be 180 minus X. And if I continue with parallel lines, alternate interior angles are congruent. So I can continue over here. X, these two angles are congruent, so this one must be X. These two angles are congruent, so this must be 180 minus X. And then I can continue on looking at vertical angles. These are congruent, and so then are these. So no matter what happens in a diagram when I have a transversal and parallel lines, for any two angles I pick, they're either supplementary or they're congruent. Our next theorem is theorem 43. It says, in a plane, if a line is perpendicular to one of two other parallel lines, it is perpendicular to the other. So I have this diagram so that I can illustrate what's meant by the theorem. I know that A is parallel to B and that C is perpendicular to A. It doesn't say C is perpendicular to B. However, if I know these two things, I can draw the conclusion from this theorem that B and C are perpendicular. Theorem 44 says if two lines are parallel to a third line, they are parallel to each other. Another way of naming theorem 44 is the transitive property of parallel lines. So looking at this diagram, if I know that A is parallel to B, let's mark that. A is parallel to B, and further, B is parallel to C, I can then conclude that A is parallel to C. Here's an example. I know that C is parallel to D, and I want to find the measure of angle 1. So I would like you to give this a try, solve it algebraically, and try then to find angle 1. Press pause on your video. When you're ready for the answer again, press play. So, since alternate interior angles are congruent, I know that 3x plus 5 has to equal 2x plus 10, so I set those equal, and I solve for x. Once I have x is equal to 5, I plugged back into 3x plus 5 to find the measure of this angle here, and I find that's 20. Then, because I know vertical angles are congruent, the measure of angle 1 must be equal to 20 degrees. Angle 1 is congruent to this. Now, here is a proof that I'd like you to try. We're given that FA is parallel to DE, FA is congruent to DE, and AB is congruent to CD. And you'll notice there's some triangles in here, and I'd like to prove that angle F is congruent to angle E. You're going to do that by proving first that the triangles are congruent, and then using CP/CTC. Press pause on your video, and when you're ready to see the answer, press play. So here is the answer. It says that FA is parallel to DE. That's given. Based on that information, I know that angle A is congruent to angle D. They are actually alternate interior angles. So my reason here says if parallel lines, then alternate interior angles are congruent. I'm further given that FA is congruent to DE and AB is congruent to CD. Well, that's not one of the sides of the triangle, but from that I can conclude that AC is congruent to BD by the addition property. I'm adding BC to both of these segments here. So now I know that AC is congruent to BD. So I'm ready to prove that my triangles are congruent. Triangle FAC is congruent to triangle EDB by side angle side. And then therefore I know angle F is congruent to angle E by CPCTC. The final problem that I'd like to do today is called a crook problem. And we're given that these lines are parallel. And I want to find the measure of, I want to find x. So the way you do this type of problem is you draw in some parallel lines at any place where my segment bends inside those parallel lines. So I'm going to draw a parallel line here, and I'm going to draw one here. And then we use what we know about each of those types of angles involving parallel lines in order to find the missing angle. So if I look here, I know that these two angles are congruent because they're alternate interior angles. I'm going to make this larger. So this angle here has to be 20 degrees. Further, I know that this angle and this angle have to be supplementary because they're same side interior angles. So this has to be 80 degrees. I then know that this angle here has to be 10 degrees because these two angles have to add up to 90. Further, I know that this 10-degree angle is congruent to this angle here because they are alternate interior angles, so that's 10 degrees. And now I know that angle X has to be equal to 10 plus 20 or 30 degrees. All crook problems are done in this way, where you draw a line parallel to the other two through any place where the segment in between bends. Take a look at the assignment that's posted today and have a great day.